Hello students, in this video I am going to explain about the principal, instrumentation and application of mass spectrometry. Contents: introduction, theory, instrumentation, mass spectrum, and about parent ion, metastable ion peaks, McLafferty rearrangement, applications. Mass spectrometry is a powerful analytical technique used to quantify known materials, used to identify unknown compounds within a sample, used to elucidate the structure and chemical properties of different molecules. The entire process involves conversion of sample into gaseous ions and then fragmentation. And then these fragments are categorized or sorted out by mass to charge ratio. And the spectrum is the mass to charge ratio of the ions versus their abundances. Mass spectrometry is the most accurate method for determining the molecular mass of the compound and the composition of the elements present in the compound. In this technique, molecules are bombarded with a beam of energetic electrons which remove the electron from the molecule so that positively charged radical ions are formed. This radical ion being highly energetic means unstable, so undergoes fragmentation. The radical ion and other fragments are separated according to their m by E ratio, where m is the mass and E is the charge of the ion. And then the record, that is the mass spectrum, is the graph between relative abundance and the m by E of the species, especially positive ions. No two compounds will have the same pattern of the mass spectrum. Mass spectrometry is not a true spectroscopic technique because it doesn't involve the absorption of electromagnetic radiation, just like UV, NMR or the IR spectroscopy. But anyhow, it as a supporting it's a supporting technique to elucidate the structure of a molecule. For most ions, the charge is 1. So that means m by E ratio is simply the molecular mass of the ion. For example, neopentane, molecular formula C5H12. The molecular mass is 72. So there is a molecular ion peak around 72 for neopentane in the mass spectrum. Theory: a parent ion results, this M plus, results when one electron bombards a parent molecule. The ionization reaction, so this is the ionization reaction. The ionization reaction requires energy in the form of electrons, photons, electric field, heat or electric discharge in the order of 70 electron volt, which is approximately equal to 6688 kilojoules per mole of energy. The m by E value of parent ion is equal to the molecular mass of the compound. Giving sufficient energy to this molecular ion, further decompose to produce new ions. The parent or molecular ion represent the intact molecule which has the same molecular weight as the starting molecule M, because the electron that is lost has got negligible mass. Only the positive charge fragment ions travel towards the detector and give rise to the maxima in the, or give rise to the peak in the mass spectrum. The neutral particles are not detected in the mass spectrometer. Negative ions are sometimes detected. Next we will see about the instrumentation part. Stages and components of mass spectrometer. There are 4 key stages in the process of mass spectrometry. They are ionization, acceleration, deflection, detection. So this is a block diagram for the mass spectrometer, consisting of the components of the mass spectrometer. So the first stage is ionization in the ionizing chamber. So whereby the sample is bombarded by electrons which come from the heated metallic filament. So electrons comes out from the heated metallic filament, and these electrons, they are traveling between the ion repeller and the electron trap, which are anode and cathode. The electrons run in a stream between the cathode and then the anode. When the sample passes through the electron stream, high energy electrons in the stream removes the electrons from the molecule, and then the positive ions are coming out. Acceleration is the second stage. Acceleration is a simple step where the ions are placed between a set of parallel plates that are charged. The ions will then be repelled by one plate and attracted by the other plate. So there is a slit cut in the plate which ions are attracted to. The force of attraction and repulsion forces of the ions through the slit at an accelerated rate. The speed of acceleration can be adjusted by changing the charge on the plates. So now the positive ions are accelerated. So next stage is the deflection. Ions are deflected by the magnetic field surrounding the instrument. The amount of deflection depends on the mass and charge of the ions. The heavier ions are not reaching the detector, and the lighter ions are also not reaching the detector, because the lighter ions are deflected more and the heavier ions are deflected very less. So the ions at correct mass and charge travels to the detector. So next stage is the detection. When the ion stream reach the detector, so there is a mistake here, not they hit a wire. On hitting the wire, they become neutralized by an electron jumping from the metal wire to the ion. Okay, when they hit a wire, the electron from the wire jumps to the ion, so that the positive ion is neutralized. The amplifier picks up on this current. So there is a current flow between the wire and ion, and that is being amplified and then detected. So the electrical signal is now recorded in the as spectrum, mass spectrum. So that is nothing but the mass by charge versus the abundance. So this is the diagram of mass spectrometer. So it consists of ionizing chamber, accelerator, deflector, and then detector. So first the gaseous molecules, so that are produced from the sample, are ionized, and then these ions are accelerated. Fragmentation occurs, and the ions are sorted out according to their mass by charge ratio. So the heavier one is not getting deflected much, but lighter one is getting deflected much. The ions of correct mass by charge ratio only reaches the detector. Then the recorder is the abundance versus the M/E value. So mass spectrometer should produce ions from the sample in the ionization source. Should separate these ions according to their mass to charge ratio.